Here we see two blocks that seem to be tied together, like so. Now we might even think, since there's two bodies, looks like a system, two bodies, the midpoint between these two would be here, and this one has a greater mass, so the center of mass would be a little bit closer to that one, so maybe that's the center of mass. We don't really know what's going on. This figure 1 might imply that this is above the ground, like so, and that these two things would drop, but we don't know for sure. We have a velocity time graph. We Euler that. Our origin. We have velocity with normal units, time with normal units. So therefore, we'll be able to read velocity and time. The gradient delta V over delta T is the acceleration, and the area V delta T, meters per second times seconds, is meters, which is the displacement. So what we can see here is that we have a velocity that is increasing. It looks like a straight line, so it looks like the acceleration is constant. Now we could calculate it if we wanted to. We see that there is 5, and this is a change in 50, so the acceleration is 10. Oh, that suggests free fall, right? And so whatever's going on here might be a good assumption that this XY thing is falling. And that was the data for block X. So indeed, block X, this block was accelerating with acceleration of positive 10. Now, it must be in this case that this is the positive direction, that's the negative direction if it's getting faster in the positive. So now we have this next graph. Its velocity time graph looks relatively the same. And lo and behold, we have the slope, which is 50 over 5. So again, we have the acceleration equals to 10. And that would come as no surprise that block X and block Y would both accelerate at 10 meters per second if they were in free fall. But again, this is all supposition. So now, experiment, two blocks are tied together by a rope. It's dropped from above the Earth's surface in the orientation shown. And we have a motion detector, it says right here, underneath each of these objects, getting the position. So if this is the positive direction, then being measured like so. Block graphs 2 and 3, positive direction. The change in momentum for the system containing block X and Y is most nearly. Well, the change in momentum is m delta V. And the mass of the system is 2 plus 3, or it's 5. And the velocity for both of them goes from 0 to 50. So the change in velocity is 50, and that's 250 kilogram meters per second, which would be choice D. Now that seems like an awful lot of work for a simple question. So this question may not necessarily be so much about the physics, but about your ability to forge through all of the questions, all of the writing and graphs and all that are given to you.